In this video, we'll be discussing various concepts of physics that apply to Angry Birds, including projectile motion and how to describe a bird's parabolic path. Gravitation, where we'll figure out how gravity influences a bird's motion. And finally, the conservation of momentum and how it applies to various birds' power-ups. The most notable application of physics in Angry Birds is projectile motion. To properly analyze projectile motion, we must deal with the x and y directions independently. Horizontal motion is quite simple. Just remember that horizontal velocity is constant, meaning acceleration is zero, giving us the formula horizontal velocity is equal to displacement over time. The one problem we run into is how do we measure displacement? In this video, we'll use the length of one red bird as a measure of distance. In this example, the distance between the slingshot and the obstacles is approximately 18 red birds. To calculate horizontal velocity, we'll fling the bird horizontally and take some measurements. It was determined that red travels 32.5 reds per second. When considering motion in the y direction, remember two things. 1. There is a constant downward acceleration of g, and 2. Vertical velocity is equal to 0 at the object's highest point. These factors enable us to use constant acceleration formulas. In this example, we'll fling the bird vertically and try to use constant acceleration formulas to determine the initial vertical velocity. The bird traveled a vertical displacement of 5 reds in about 1.1 seconds. We must also remember that the highest point, the vertical velocity is equal to 0. Using the correct kinematics formula, we can determine that the initial vertical velocity of the bird was 9.1 reds per second. Now that we have examined motion in both the x and y directions, we can now bring them together to fully analyze the bird's motion. Because the bird follows a parabolic path, we can say that the motion as a whole is symmetrical about the highest points. And given 2 points equidistant from this axis, we could say they have equal speed in opposite direction. If you have both horizontal and vertical velocity, you can use the Pythagorean theorem to find velocity. The next topic we'll be discussing is gravitation. On Earth, gravitational force is the product of mass and the gravitational constant. But in the case of space, it's a whole nother ballgame. Each planet has a unique gravitational strength, so we need a new formula. Gravitational force is given by the following formula. If we know the distance between the bird and the planet's center of mass, along with the masses of the two attracting objects, we can determine the force of gravity. While we play Angry Birds Space, the birds sometimes have enough speed to escape the force of gravity. The velocity necessary to escape the gravitational field is called the escape velocity. The final concept we will discuss is momentum, which is a product of mass and velocity and a measure of how hard it is to stop something. To better understand the concept of momentum, imagine this. Let's say you are the target of the Angry Birds. Would you rather be hit by blue, red, or bomb bird? Chances are bomb bird's going to hurt the most. Because of its larger mass, it will have the greatest momentum. Now let's say you have 3 red birds, one that travels slowly, one that travels at a moderate pace, and one that travels quickly. The bird that travels quickly will have the largest momentum because given a constant mass, it has the largest velocity. An important topic that applies to Angry Birds is the law of conservation of momentum, which states that in an isolated system, momentum is preserved before and after a collision or separation. This is especially important when talking about the bird's power-ups. Have you ever wondered why the white bird deflates and goes off in a wild direction after releasing its egg? The purpose is to maintain the conservation of momentum. Now that you know the basics behind the physics of Angry Birds, it should be easier to play the game now and actually win.